So I'm here. Some of you may have heard of this project a few times around here. Theoretically, I'm here to talk about this, but I actually have a surprise. It's going to be interesting. Okay, so this is observatory as it currently exists. I think pretty much everyone knows this project so well, even if they haven't looked at the code, because they look at it, I would hope, fairly frequently. I just wanted to bring us up to speed that we now have all these people who have contributed to observatory, and possibly some people that it hasn't picked up because it's not smart or something. So how can you get involved? Well, it's pretty easy. If you go to GitHub, we've got this issues page over here, and there's a whole list of things that are wrong. Let's find one that's pretty easy. Don't display projects without images as featured projects. All right, how would you go about fixing this? Well, we have a project object, right, theoretically, talking abstractly. There's probably a project object, and it's probably got some screenshots. So if it has none, don't show it. Someone fix that, like tonight or something. All right, now for something completely different. All right, chocolate or cocoa. Specifically, the main UI framework to use on the Mac. You build it with Xcode. Step along. In a web browser, like Firefox, Chrome, or Safari, the ones that aren't bad, Chrome and Safari come with this tool. Firefox, you get it as Firebase. There's this kind of like inspector thing where you can look at the layout of your website. You can change the CSS properties to do debugging. You can alter the hierarchy, anything like that. All right, but what about on the desktop? Well, in the Linux world with GTK, there's this guy called GTK Parasite. It looks like this. It's a GTK module that you run with your program. And you can access the entire hierarchy. You can see properties. And down here there's like a Python shell apparently. I didn't know that existed until I saw the screenshot, so that's kind of cool. But what about on the Mac? Well, there isn't one. Until now. It's called Loompa, because it's like a chocolate inspector. How does this work? All right, well, Loompa is a distinct application. Say this one over here. And we've got another application over here, this one. Now I want to look at the windows of that application and then the view that's in that. The windows have a root view, so I want to look at the view that's in that window. And then I want to look at the view hierarchy below that view. Views have subviews, etc. So this one's got some windows, and I want those windows. So how do I get them? Well, the first thing I was looking at is I clearly need to put some code into this application. So I was looking at something called mock inject. Mock is the Mac OS X kernel, if you're wondering. Sort of. What this mostly got me was segfaults. And so I'm going to revisit this at a later date. But I decided to do it a different way. So to the rescue, build the insert libraries. For those of you on Linux, this is LD preload. So what this does is it's an environment variable you would set when you're going to run a program. And you give it some libraries, dynamic libraries. And it will run those libraries' initialization function and load that library's code before the other program starts. Okay, so now I have a way to get code into someone else's application. That's cool. Say I have an application like address book. The address book has some code in it. I take my program, which says hello world, or my library, which says hello world, that's initialization function. I stick it in there, and address book says hello world when it starts. Pretty cool. All right, so how does this help me get the windows out, though? I mean, I made that myself. Cocoa has this thing called distributed objects. And what that does is, this is what it looks like roughly in terms of like a class structure. So what that lets you do is you can have objects and you can share them through a connection across processes or even over the network across different computers. So it's pretty cool. Across processes is something really fast because it's on the same computer. The network stuff would be slower because just even network ping is slow. So basically you set up a connection, blah, 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 blah. And when you call at the top, when you call methods on that object, it goes all the way down here, calls that method, and then goes all the way back up. But to the developer, it just looks like a normal method call. So what we do is we inject into that process, we set up a distributed objects client in that process and connect to the server that's in Loompa. And so each one has a name, that's how you identify them. So it's just Loompa DO connection and then the PID of the process. So it's unique. Okay, so that's cool. So now we have my process, which has my library in it, talking back with Loompa process. So what can we do now? Well, why don't I just show you? I should have had this ready to go. Sorry, I'm going to start at Xcode. Yeah. Bounce, bounce, bounce. There we go. Okay. Oh, they're mirrored, so off. Xcode 4 is very slow to load.
Should get an SSD, Nate. Come on. Join the real world.
Okay, here it goes. Here it comes. Okay. Okay, so here's what it looks like. So these are all the currently running applications. Theoretically, you could inject into them. You can right now. So what will happen is it'll actually just start a second index or a second instance. So I'll just go and I'll launch a process. I can choose between all these wonderful applications. Let's inject ourselves into system preferences. So system preferences starts up. It's on this screen, so I'll move it over. And you can see there are two windows here. I'm not sure where the second one is, but apparently there's a second window. Later you'll be able to figure out what's going on in the window. Right now there's no inspection. You can't inspect windows. You can just inspect views. Okay, so here's a view. It's got these little collapsy things. You can alter the frames of views. So that's the X position and the Y position in its super view and the width and the height. And what we're doing right now is looking at the properties and the instance variables of each down this kind of the subclass chain of each class. So you can see these are all NSView, which is the base Cocoa view class. Those are all the instance variables in NSView, which is kind of cool to look at, because you can't, in Objective-C, instance variables tend to be private, just so people know. So let's take, so this I think is the main, wow. Yeah, so this is the main view, this whole area here. So just start kind of like deleting stuff. And what I'm going to work on eventually as well is you'll be able to pick this up and drag it and put it in a different view. That's not really like the main purpose of this application, but it's just a cool side effect. And so what else can we do? It won't work with preferences actually, so never mind. Yeah, so I was working on this last night, and I was working on this thing, which is a little collapser, right? So it collapses, and everything else adjusts. So everything else moves up, and things weren't showing up. And I was thinking, wow, if only there was some way to look at like the frame and the view hierarchy of my application. And that's when I realized this was a really good application to write. So I'll switch back to. Anyway, okay, so this is probably the last time I'm going to present here at RCOS. So I just like to say,
maybe we will invite you again.
Yeah, maybe. So thanks to Morthy for running RCOS and all of that. Thanks to Sean O'Sullivan for making RCOS possible. And thanks to everyone here for doing awesome presentations, awesome projects, even awesomer presentations after they heard the previous presentation and have some new ideas. And giving feedback to me, which is what I'd like you to do right now.
First thing, you have to put this in the dashboard.
Okay, yeah. It's on GitHub. Oh, it's BSD licensed for the record. Just,
no, you have to put it in the objective.
Okay, yeah. I'll do that after I sit down.
Right, yeah.
Well, I shouldn't, because I would be using my laptop.
Oh, no,
and my laptop's staying here, actually, so. I hope I brought the technicality of that down enough, because I know most people here aren't Mac developers.
But
except for these two people and me.
It was clear.
Yeah, okay.
The idea is broad.
Yeah.
What about like Loompa over the network, or how specific are Loompa?
So,
like how tied to AppKit and Cocoa is it?
So it's very tied to AppKit. Well,
could it be used for another UI framework developed by Apple that runs on mobile phones?
Yes. Yes, it probably could be. Yeah, there's nothing, well, okay, so it does have some like NSVU and MS Windows specifics. So obviously you could switch that to like the frame stuff and the auto resizing stuff is obviously very NSVU specific. But there's no reason you can't make a UI view version. As to over the network, there's no reason it couldn't work. The main issues are one, getting the library there, because right now it can just reference, because the library is packed into the application as like a resource file. Applications on the Mac are just folders, by the way, with an executable, and then the OS represents it as a single file. So you can just put arbitrary stuff in there. It's really nice. In the resources folder, that's where the library is. So it's really easy to reference that to set an environment variable. So you need to add like SCP or rsync or something to do that. But besides that, there's not really any, assuming DO exists on the iPhone, which there's not really any reason to, because it's not really allowed.
I don't think it's there.
Yeah, like multi-process communication isn't really allowed. The question is whether or not they bothered to remove it or not, which they probably would, because it does take up a small amount of file size and is a vulnerability, I guess, in a way.
When you presented it, reminded me immediately of Emacs advice feature. I do not know why that reminds me of advice feature in Emacs. And so the follow-up question is whether this could be used some other view could this be used by people who are handicapped? That was what my question.
Okay, so first of all, I use Vim, so I don't know what you're talking about. But there's already like I could see it being used. There's actually Apple provides like an accessibility API, which is what a lot of people that do like kind of like weird hacky programs that mess around with Windows use the accessibility API, because you can do like you can get the contents. I think it's just as strings though, and like the position of the window, and you can move the window around. So this is like probably too much for that. It wouldn't make sense because there's actually like an officially approved way to do that, short of like injecting yourself.
4 years ago it was not good. At least that's
I know. I don't actually know of any. I mean, I wouldn't have a use case for it because it wouldn't apply to me. But I don't know any. I don't know any instances of the accessibility API being used for like accessibility. Pretty much all of it is just like system hacks and like making OS 10 into a tiling window manager or something. But yeah, you could use this for that, but it seems a little excessive, and it's a little leaky, which is okay because you're just debugging, and you're gonna kill the process in a few minutes anyway. But for long-term use, I really have to look at the memory links. The problem there is that Objective-C right now on the Mac, you can choose between like garbage collected and not garbage collected, which is then manual reference counting. So you have to support both basically. If you can mark a library as working with both, but then you have to make sure it actually does work with both. Obviously, garbage collection doesn't take much work, but you have to make sure the manual stuff works. Because I was injecting myself into Apple's Mail app. Before I flipped on the optional garbage collection in the library, it just crashed because Mail is garbage collected. But that's a total sidebar at this point from the original question, so. Yeah.
I saw you were listing out all like the member variables of like the object, like the view class. Is that an Objective-C specific thing? Like, does Objective-C provide a way for you to do that? Or
yeah, Objective-C is roughly as strict about like keeping its things hidden as like Python is. Okay. It's just harder and not necessarily like sanctioned by the people that typically use it, like it is in say Python or Ruby. Like in Ruby, where it's the norm to like open up a system class and change it. It's like just like okay. You can do that in Objective-C too, actually. But yeah, it's I'm using another open source thing for that, which is just the Objective-C API is a C API. Objective-C is a strict superset of C, if you didn't know. So the Objective-C API that you normally do that through is a C API, and someone wrote, I think for like obvious chicken and egg reasons, and someone wrote like an Objective-C wrapper for that, which makes it really convenient. Like you can just get a class object. Classes in Objective-C are just objects too. So you can get a class object and you can ask for its properties, like you would ask for say the members of an array. which makes it really easy. The only problem is that this is where this project in particular gets complicated, because you have to be doing this stuff in the process that you're injected into, because that process might have classes that that my process doesn't have. It typically does, actually, because a lot of people have subclasses of stuff. That's sort of how you write code. And in Cocoa, at least, like subclassing is very prominent versus like property setting. So that wouldn't work because the class isn't in my assembly; it's in theirs. So it's a little complex, like handling. Like Loompa itself has to mostly deal in like strings and stuff, and then send that back and keep converting strings from types and types to strings. Yeah. Okay.